All right, I was kicked out. Are we live again?
Yep, we're live,
Or are we
and
live?
I don't see your screen at this point.
Okay, yeah, I got kicked out. I had to get back in the meeting. Get right back in it. Hold on here. All right, are we good?
We are good.
Okay. Let's kick it off here. Welcome, everybody. My name is John Starr. I am with the Nebraska DOT here as an engineer and technology leader, and I'm also part of the Highway Engineering Exchange program, who is sponsoring and hosting this webinar. So, I'd like to welcome everybody today, and I'm going to kick this off. Um, so today's webinar agenda, we're going to start out with an introduction, which I will lead here for the first 5 minutes or so. I'll then turn that over to Aaron Chamberlain and Timothy Haida from Caltrans, and they will navigate through about a 15-minute presentation, and then we'll reserve about 5 minutes for Q&A. We'll roll from there into Ryan Marlowe and Alaska DOT, and kind of the same time frame with about 15 minutes of presentation, 5 minutes of Q&A. And then lastly, with about 10 minutes left on the hour, we'll turn it over to, I think, James Gray from the FHWA to lead a little discussion on some UAS data standards and pooled fund research projects. So, kind of moving forward a little bit here, the folks who are going to be involved in speaking today, number one, from HEAP, we'll have Thomas Hamsky with a brief update on the IHEAP 2024 conference. Already introduced myself, and Aaron Chamberlain representing HEAP as the Area 4 Director and also representing California DOT, along with Timothy Haida, Ryan from Alaska, and James from the FHWA here. We just a little bit about HEAP. I don't know how familiar everybody on the call is with HEAP, but Highway Engineering Exchange Program. It's a nonprofit organization led traditionally by state DOT volunteers. Our focus is really on engineering technology, implementation of those technologies into our transportation business practices. So a few different things go on. Number one, we host a yearly conference, which has been growing in popularity over the last few years immensely. Thomas will update us on that. And also, over the last few years, been hosting some webinars throughout the year. So 2024, we planned 6 of them. This is number 5. I'm just kind of giving you a snapshot here where we are in the process. You can look up the HEAP YouTube channel and get back to any of these other recordings. And of course, register moving forward for anything that is open. A little about the logistics of today before I turn it over to Thomas. Number one, everybody should be muted and will stay muted until we unmute. Any Q&A, I believe, can go through the Q&A function in Teams. If I'm wrong there, Elaine, please chime in, or in the chat. So we will kind of monitor as the presentations are going on, and then with the time we have left, we'll pick some questions out to get answered. I think that is the most of the logistics we need to go through. So I'm going to turn it over to you, Thomas, to give us a quick update on IHEAP 2024.
Thank you, John. As mentioned, my name is Thomas Hamsky. I am the current president of the HEAP organization. I represent Iowa Department of Transportation, and we are hosting a conference in Des Moines, Iowa next month. We are a mere 16 days away from the conference, and looking very excited to hosting so many folks in my home state to kind of bring what we have, as well as looking forward to all the sharing that's going to happen the whole week. It's a great conference. Unfortunately, we are completely sold out at that capacity. So if you're hoping to get in, it's a little late. We've been sold out for a couple weeks now, and we got as many as we could into the conference for what we had for our venue. So if you were hoping to get in, sorry, it's sold out, and it's not looking like we're going to get many more people in. But there's always next year in South Carolina. A couple things to note. I did recently send out, if you are registered, I did recently send out a survey. If you have food sensitivity issues, let us know so we can kind of accommodate you, as well as if you're attending the Sunday Icebreaker, we have a waiver that needs to be signed by all people that will be participating on that. So you should have got an email about that last night. And then also, if you are a state DOT, we did send out a survey to kind of help facilitate our roundtables that we'll be doing on Sunday of the conference. Hoping to be able to have those filled out by the end of next week, if possible, and that'll help facilitate the conversations for our roundtables. It's going to be a great week. We've got a great set technical program and good presentations the whole time, and I'm looking forward to seeing everyone who is able to come in next month. So thank you very much.
Thank you, Thomas. That's going to end my introductory portion here. So, Aaron, I'm going to stop sharing and turn it over to you guys.
Absolutely. Yeah. Hi, everybody. Aaron Chamberlain. I'm the newly elected Area 4 Director from HEAP, representing the HEAP organization. So Area 4 is kind of West Coast. So fortunately, I'm here to introduce our surveys branch from the Office of Land Surveys from our San Diego region, and then later Ryan Marlowe, who is from Alaska, who's also in Region 4 from Department of Public Works and Public Facilities. So with that, I will hand it over to Mr. Tim Haida, and he also, I guess, as a co-presenter, Mr. Jacob from our Office of Land Surveys group. So with that, Tim, go ahead and take it away. And looking forward to you showcasing the advanced surveys technologies that Caltrans is now employing.
Thanks, Aaron.
Yeah, so I wasn't sure which pieces, Tim, you were going to do and which piece Jacob was going to do. So
Yes.
feel free to riff on that.
Great. Thanks, Aaron. And thank you for the opportunity to speak today. Yeah, my name is Tim Haida. I'm a transportation surveyor with Caltrans, and I lead the office support team for District 11 field surveys based here in San Diego. And I'm here with my colleague, Jacob Lopez. We're both involved with District 11's mobile laser scanning program, UAS program, feature extraction, survey delivery, testing new survey instruments and software. So Jacob's here too to help field any questions anyone has. So one of the great things about working for District 11 field surveys is that we're constantly looking to improve safety and efficiency by adopting and integrating new survey technology. So different survey platforms have different strengths, and we continue to innovate by combining multiple platforms to collect survey data as safely and efficiently as possible. Our goal is always to minimize the amount of time that our survey crews are on the shoulder. So we're always looking to stretch the limits to minimize that and keep our staff safe. And so today I'll be highlighting in the first part of this presentation 3 of our reality capture platforms and how we recently integrated all 3 of them to complete a preliminary topographic survey for the construction of a bike trail under Interstate 5 here in San Diego County. So first off, this is our Trimble MX9 mobile terrestrial laser scanner. It's permanently mounted on top of Chevy Tahoe. It has 2 laser scanners. There you can see it has two laser scanners capturing 2 million points per second and 360-degree camera up on top that is capturing panoramic photographs at the same time. So this allows us to drive at a speed of usually 45 miles per hour, which gives us a point cloud that's dense enough for feature extraction. So for our project on Interstate 5, this is the final point cloud from our mobile scanner. And so this is just 4 runs or passes of the vehicle, 2 on the innermost lanes, and then 1 on each outside lane. So you can see that the result is a dense and accurate and precise 3D representation of the whole roadway. And it's very efficient. We're driving it at 45 miles per hour. So the start to finish, this whole scan took just under an hour. And so in this case, the bike lane was going underneath the freeway. And so the mobile scanner obviously captures everything that's visible while driving down the freeway, but nothing underneath the bridges. And so for that portion of the survey, we utilized our Trimble X12 stationary terrestrial laser scanner. So this is just the same technology as the mobile scanner, but just mounted on a tripod. So this allowed us to set up underneath the bridge and capture a full 3D point cloud in just 9 setups. A great thing about the X12 is it is very fast. You can get a full dome scan in about 6 minutes, and it also has a great range on it. I believe the range is up to 800 feet, and so the result is a really dense and detailed, accurate and precise point cloud. And then finally, we employed our FreeFly Astro drone. The video here, it's equipped with our LiDAR payload, but in the case of this survey, we had it just our regular camera for photogrammetric mapping. And here's the dense point cloud from that drone flight. So this was really to capture the wider area that wasn't visible from the mobile scan down off of the edge of the roadway. In this case, the engineer was really interested in getting a detailed surface of the boulder riprap down around the edge of the water. And so we utilized the dense point cloud from the photogrammetry mission to supplement the LiDAR data from the mobile scan and the stationary scan. So combining all 3 of those point clouds from the mobile scan, stationary scan, and the drone flight, our office staff extracted the roadway, bridge decks, soffit, original ground, and the boulders that I just mentioned for the design data survey. Here are with the triangles and the contours displayed for the final surface in Civil 3D. And so by adopting and combining these 3 reality capture platforms and our suite of feature extraction tools, we're able to deliver a design grade surface efficiently while really minimizing the amount of time that our staff were out on the shoulder of the freeway. And there you can see how detailed the final surface was of those boulders. Just a couple other use cases for our mobile scanner that I wanted to highlight that we recently used it for bridge clearances on Interstate 8. And here is another very detailed survey of the Coronado Bridge toll plaza here in San Diego. If anyone's been to traveled to San Diego, they're probably familiar with the Coronado Bridge. And as you can see, the amount of detail in this would have conventionally, taken several weeks to complete. And in this case, with our mobile scanner, it's just a matter of a few hours of scanning out in the field, and then about a week of extraction in the office. So that completes my first part, and then so I just wanted to also highlight some of the recent integration or use cases in our UAS program here in District 11, and how they've helped us improve safety and efficiency. So this is the Wingtra, which is a fixed wing drone. You can see here it has the vertical takeoff and landing functionality. And so it really gives you the best of both worlds. You can, obviously launch it and land it in a small area. You don't need a big, area like you traditionally did with a fixed wing drone to take off and land it. And because it's fixed wing, it can cover, a much larger area. It flies at 35 miles per hour in a much shorter amount of time compared to like a quadcopter drone, and uses less battery. Here it is landing again, and it flies fully autonomously. So it basically sets a waypoint for home, and then it finds its way back. Has a 42 megapixel camera to capture photos, which we then process to reconstruct a 3D photogrammetric model of the site. So shown here is at the new port of entry down on the Mexican-US border. This is a 200-acre site where they're actively grading, and this was flown with the Wingtra in just 45 minutes. Just as a comparison, before we had the Wingtra, we had flown this with the quadcopter, and it took about 8 hours, mostly because we had to swap out the batteries multiple times, and also just the speed of the drone platform itself. So that was the Wingtra. So we continue to test other new drone platforms and payloads. So here's the Skydio X10, which Aaron kindly demoed for us here. And it uses 6 4K 200-degree cameras to capture photographs, and also utilizes AI to fly autonomously and avoid obstacles. And again, this is with the Phoenix Recon A LiDAR sensor on the FreeFly Astro drone. So this LiDAR payload scans at 240,000 points per second and has the ability to capture multiple LiDAR returns. So the multiple return capabilities allow us to filter vegetation from the point cloud to produce a bare digital terrain model. So that covers everything I wanted to highlight as far as our new technology that we're implementing here in District 11 to continue to improve safety and efficiency in our field to design workflow. So if anybody has any questions, we'd be happy to take them.
Don't be shy, everyone. Ask away. So first question we have is, what software did you use for feature extraction?
We use Topodot, which runs within MicroStation.
Mics are unmuted, so if you want to raise your hand, and then you can unmute and ask a question in person.
Next question I saw coming in is what sensors on the Skydio X10? So Caltrans has both. We have the Z and we have the L gimbal as well. So we're actively testing the new L gimbal for photogrammetric purposes.
How are those models coming out? It's easier.
So far, so good. We don't have RTK yet because they have not started shipping those modules yet. So we're hoping those will improve with RTK.
Okay.
But so far, without RTK, if you have enough ground control, we're seeing pretty good results out of them.
Okay, that was my next question. Appreciate it.
So another question I see is why use mobile LiDAR over UAS LiDAR?
I can take
Tim,
that
you want to
one.
handle that one?
Yeah, with our mobile scanner, we can achieve design grade accuracy. We're not able to, I should say, specify vertical accuracy. The UAS LiDAR is not to that level of vertical accuracy for our design purposes. And another reason, which Abe mentioned, is flying over roads. And so, yeah,
question. I typed it in.
Yep, we're
It's an
unable
FAA
to
tool.
fly over live traffic. So in this
There
case,
you go.
yep, we had, you could see in the model that the field of
Uh-oh, we lost audio there.
oh, sorry, can you hear me?
Yeah, you're good now.
Did you?
You have one hand up from Melinda.
Yeah, I was just going to ask about control and accuracy. I mean, did the scanning time include your setting all your control and your collecting your accuracy points and checkpoints and stuff? And then did you create an accuracy report for all the different types of scans that you produced, and just kind of wondering how that documentation was done, or if it was?
Absolutely. I think I was accidentally muted for Abe's question, so I'll just briefly touch on the flying over the roads. So yeah, we're unable to fly over live traffic. So in this case, we flew to flight lines going down the right of way adjacent to the freeway. But that definitely is a challenge because we have to fly at a flying height that allows that field of view to cover the roadway. But in this case, we still had the adequate coverage of the boulders around, which is we were more interested in picking up features that were off of the freeway. But certainly is a challenge. As far as the question regarding the control and the accuracy, so yeah, so a significant part of these missions is setting the control and planning the control as well. And so that involves setting targets for the mobile scanning. For these design grade surveys, we place a reflective target on the shoulder every 500 feet. And so there's the control report associated, with establishing the values on our control points. But then in addition to that, we carry out independent checks using conventional survey methods. So in this case, with a total station, and to verify that these reality capture methods are in fact meeting the design grade specifications, and then produce a report of those checks.
Yep, another question just came in. Do you keep various point clouds data sets separate, or do you merge them for processing? And then a follow-up question on top of that was, do you perform classification on those point clouds?
We do keep them separate just because of the varying accuracies of each of those. But when we are extracting, we do have the ability to view all of them as we are extracting. So a little bit of both, but we don't actually merge the files themselves. For classification, we do carry out, for example, ground classification, which can help to eliminate vegetation if we're wanting to produce like bare earth DTM.
Hey, Aaron,
Yeah, are you-
John here. I know we're on a time check. Maybe one more question and then turn it over to Alaska. I don't know if you caught that, Aaron. I guess I was
Yeah,
suggesting maybe
I
we
don't
take
see
one
any other
more question.
questions,
If there
so I
are any
think we're
more
good.
questions. Yeah, thank you.
Yeah, so with that, I'll turn it over to Ryan from Alaska.
Thank you.
Thank you, Tim. Yeah, and also if anybody else has any more questions, feel free to keep it typing, and we can keep an ongoing chat going on the meeting chat or in the question or in the Q&A section.
Perfect. Well, I'm Ryan Marlowe from Alaska DOT, and as always, I like to start my presentations with an AI-generated slide of something wild happening with drones and technology. So I have no idea what's happening in this photo, but I'll let you guys decide moving forward. So as always, I love to start presentations on this is the most text you'll ever see on my presentations on big video and photo, but very important to show where we're coming from and where we're going, a lot of the trend analysis, and then of course, Alaska in general. So for us, we've seen a massive growth in a lot of the highway collection data, construction management, but really for us, our geotech groups and materials are starting to develop a lot of the technologies for landslide assessment and avalanche. And then just how to collect that data repeatable in these areas. Alaska being so wide and we having so few of workforce, this is a key one for us across the board. But currently we're sitting at 113 remote operators with about 152 systems, ranging from a good amount of different subject matter expertise. Survey and construction is the primary push with a lot of our federal projects. But really want to push hard on engaging with a lot of the peer exchanges. This is where a lot of our information is being shared with California, with other state DOTs. And as we continue to build upon everyone else's successes, those have been incredible through the ADCMS, through SMART. A lot of that, we're excited to share those with other organizations, and we're building these with the knowledge of sharing those forward. So, but really what I'm here to talk about today is drone ducks. This is something that we are very excited for. The technology is continuing to get better and better. And as we start to see this technology, the road work ahead sign is definitely there. We're continuing to break these systems. We're continuing to find things that don't work with it and really pushing these things to the limit. But we're finding a lot where we have limited workforce, getting ready for the next workforce of the future and starting to deploy these assets. So not just one organization has access to this. I always use the printer analogy of, you just send stuff to the printer and magically it just gives you a document. That's really what we're looking at with docs is magically we're going to start seeing data that is tied into control, that is using RTK, that is magically broadcasting itself across space-based communications and just magically showing up on your phone the next morning and giving you those insights. That's what we're working towards, and the standardization, the work behind it. That's not magic. That's a lot of coordination, a lot of us basically knocking on the door and seeing how this stuff is moving forward. But what I like, let me push back here 1 second. What I have here is a cool video slide of what's happening. So this is the recent Mendenhall Glacier outburst. So this is live from remote flight deck. This is Skydio's interface. So we have drones that are broadcasting live over Starlink. And so you can see a couple of the features on board. So this is the X10 platform. We're looking at infrared. We also have the Spotlight and Night Sense running, but you can see kind of the differences on how we're sharing this data. But this is being shared live as we're watching the river basically rise and start to flood and hit these items. But What we're looking at is the interface that is controlled exactly the same way on dock. So the web interface, the ease of use, the sharing of this data. For some folks, the capture of that data is important, but this is using the L gimbal that has the spotlight on there. So you can see us searching around with that, as well as the night sense on board, and basically just watching the erosion in real time. So we had systems going up and down the river, but sharing that information, getting ready to basically plan against, and then of course switching back and forth. So we're sharing this on live stream. We also have it on Teams, coordinating with folks. But overall, you can start to see the use case of, it's not just the data that's on the ground that's being connected, it's how many teams you can have. I think in this meeting, this was 2 a.m. in the morning, and we had about 50 people that were watching this, from emergency coordinators, all of which that one system is giving everybody that situational awareness. So really impressive when we talk about this as a whole is, how do you deploy this at scale? How do you deploy it across, Alaska, the rest of the nation? And so right now we're connecting and we're testing with 2 docks. So the Skydio X2 dock, and of course, all of the platforms themselves working, and the DJI docks series as well. Both of which, same exact web interface, flight planning, allowing for integration for train mapping, allowing for integration for remote operations. But Alaska operates these as a public operator. So normally when we're operating them, we're either putting up a TFR and operating with our avalanche operations, or utilizing them for disaster response. So it's something that we're still getting that true beyond visual line of sight. We are very excited for Part 108 to see what happens with that. But comparing these across the board, that's been my big item is yes, we have these technologies, but I love to test all of them. We are constantly dual deploying, making sure we're watching, hey, the live stream here, the data being collected. So you can see both these platforms. We have the Skydio on the left, DJI on the right, very similar products. But that's really what we're looking for, is how are they working in rain? How are they working in weather? How do they work at altitude? What batteries? So we're constantly checking that things as we're deploying with our teams in the field. The big item though is the behind the scenes. How are we tracking this data? How are we installing these systems? So for those of you that are big on how all this stuff connects, there's a lot that goes into just deploying a dock. I know watching Aaron deploy these and move it across the board, there's a lot more, with the solar, the power. But I always like to tell folks, like, when you are ready for this, basically make sure you have reliable power. If you don't have power, probably talk to Aaron and figure out how he's configuring his solar. But that's been a big one, is just how we're getting ready for a lot of this technology. The second one, communications. We've been very fortunate with a lot of the advances in low Earth orbit through OneWeb, through LTE, through FirstNet, and Starlink. We're seeing a lot of these really enabling the bandwidth to start putting a lot of these systems on load. With everything you see here, I think our load is on average 20 megs per second, just between the cameras, the Meraki, the voice over IP. Overall, this is really changing just what we can put at these sites and operate as if we were there in person. Weather has been a big one. So we've been putting out the Campbell Scientific Stations, which is giving us a lot of the data that's required on our COAs to be able to determine what the weather is, not only at the site with the aircraft, but at the areas that we plan to operate. So in Alaska, we are spread very thin on weather and AWOS and ASOS services. So the ability for us to have weather observers and these weather stations to dictate what's there before we take off. But the big item with these systems that we've been really excited with is the development with ICOM and the ability to broadcast VHF radio remotely. So we've been using some of the ROIP gateways where I can be in Anchorage and I can operate a system 2,000 miles away, talk with other air traffic as if I'm there on the ground, as well as monitor via the ping station for ADS-B. So there's a lot of cool technologies. Now, with a lot of this, we're putting it all into an IoT policy and looking at it as a secure item. So bringing a lot of the cloud and on-prem services for both DJI, Skydio, and locking that into a dev environment So we can still have live streaming drone data, but we're securing it on our side to make sure that that system can't call out to the internet. We're controlling those VPN tunnels and making sure that from start to finish, from point to point, we own the security, we own the pathway, the encryption, and making these systems reliable. So with low Earth orbit, those connected operations are bringing in kind of this next phase of live weather, live data, uploading all of this information. The ability for us to put vehicles out there that have connected environments through our mobile land radio, through our Starlink services, even connecting docks to vehicles. You can see here the F-150 EV has been equipped with a drone dock. Our goal with a lot of these is to put the system out in these remote places and not have to install infrastructure. We don't have enough technology to spread across the entire state. So our goal is, well, how do we build it into vehicles? So the ability to park a vehicle that has sustained power for 15 days, to run a dock, to run the communications required and be online. EV vehicles is an interesting solution for us with a lot of this technology, and then we don't have to have the environmental factors. So, of course, down there on the left, you can see we did hit a new record for Alaska, 461 megabits per second. This was during one of our responses in Ketchikan, but all of this technology tying together for the enablement of LTE-enabled systems on the Skydio platforms, the ability to push FirstNet, the ability to have the high-speed connectivity and redundancy is really bringing this next stage of how we tie all this data together, how we bring it live, and really how we start extracting insights from the field to the cloud and bringing in more members. So you can see two systems here. On the left, we have SiteScan that is basically getting pushed from the dock or from the operator in the field to a cloud environment. Our cloud environment is in Washington, so it allows for us to utilize those resources or scale them up to meet whatever we're processing. On the right, you can see a contractor deliverable that we've dumped into TBC. We've tied in that imagery, and so we're checking to see, just with imagery, did the contractor deliver what they say they did? Here's their breakouts, here's everything that they've given us. And so we're checking it to basically make sure, all right, check, check, check. So docs, as we're looking at project management, is starting to allow for us to verify things that are actually happening, and we can check those off in order. Or docs for highway safety, the ability for us to manage systems remotely, avalanche. Avalanche safety hazard index, you can see here we're basically mapping terrain remotely. This is something that we've been working on, is like, how do you have a system flying safely next to the side of a mountain? We're utilizing a lot of RTK, and then of course post-processing that data for reliability. But same thing, we're just allowing for us to do change detection, do slope prediction for runout models, but we're just looking at the volume pre-post storm and then compared to a bare earth model and detecting how much volume is now up there versus what could possibly hit the road. Now, one of my favorite things that we've been working on is avalanche mitigation. So with all of this data of precision GIS, the ability for us to carry explosives on board is something that we've been working for a while. So we partnered with a couple experts in the field to develop a platform that allows for us to carry precision ordnance. And with the insights that we're gathering from the GIS data, we're now able to go and do targeted explosives without having to do the howitzers. The howitzer platform is over 100 years old. And here we have this technology that's far safer, doesn't have any humans on board, and allows for us to deploy remotely. So the last couple slides is just talking about that data storage, data governance, how we get that data from the field, how we do it reliably, how we do it standardized, and then how we make it viewable for users moving forward. This is our current workflow, the automation workflow, where we take imagery, video, LiDAR, GIS, and vector data, and push it to our Esri environment. So what's really cool is a lot of these manufacturers are developing API draws. So here we've highlighted Skydios. Skydio then allows the API draw from that platform, from the either X10, from any of these platforms. As soon as it syncs to their media sync or cloud, it will automatically dump and start processing in site scans. And then from there, we can start extracting those insights. So bringing them into processing engines. For us, it's ArcGIS Online or Arc Pro. But how do you stack, this is our response to the Wrangell landslide. How do you stack those services across the board? By utilizing, what imagery you have. So each one of these scans, pretty good size, but now when we have 65 of them, we're looking for a change analysis for slope stability. So we're taking that scan data with what limited, ground control we have. We're showing up on site with no imagery. So we're downloading everything as we're showing up, but we're making that available through web maps, through apps, through services and Experience Builder, and then bringing all of that together and starting to tie in with some of the AI classification. So if we're looking for a certain color, if we're looking for something that's been designated as a must find, all of those things can kind of be pulled together. One of the items that I really like is the ability for us to send one person out to gather site assessment. So the ability to preload their mobile device with everything they need, the ability to tie that into either if we have any pivot or core stations nearby, they can update that information. They can fly the drone, they can do site assessments. But for us, once again, the limited workforce, we're trying to maximize the amount of information that's being collected. If we're doing realignments, if we're doing all of these things and share that across the board. So between drones, between imagery, between what phone exists in your pocket, we're really opening up the opportunities for data collection with a lot of these moving forward. And that brings me to my last item of disseminating all of these insights. How do we take that data sharing, those standards that we're collecting and the collaboration and make it available to everybody? We do that through these tools. We do that through this data, through the repeatability aspect of there. So you can kind of see in this Experience Builder shot here, how we're taking that information, overlaying it and displaying it to the public, displaying it to relevant stakeholders, during our responses. How do we take the weather data and showcase it versus erosion? These are all key items that we are very excited to see. It used to be low-hanging fruit, but because of the rapid ability to do not just daily collections, twice daily collections, we're able to see these analytics and say, oh, that's interesting. We're losing 0.05% of volume per 2 inches of rain that fall. Those are the insights that we're capturing with a lot of this data. So overall, very excited to see where drone technology goes. But if you do have any questions, please, here's my information, and I'll open up to questions.
Yeah, Ryan, so there was one already regarding the recent Ketchikan landslide, on kind of what Alaska's response was. Were you guys utilizing UAS?
Absolutely. So our teams got deployed, I believe, Monday, arrived on site. Fortunately, I don't want to say fortunately, but we've had a lot of landslides. So we've started pre-packaging and having systems ready to go. Basically, Starlink, our Trimble-based packages, a lot of these systems are basically standby for these events. So we're starting to learn the difference between, first responders and data collection. That's kind of a hard item to show up as both. Is you're trying to help with the first response, you're trying to find any victims or casualties, and then you're also basically getting ready to lay ground control and getting ready to start, your collection process. So normally what we see is we'll show up on site, we'll grab a rapid image process of the entire environment. And then from there, we have secondary teams that are taking that data and saying, all right, we're going to drop ground control here. We have a core station here. Here's the mount point. Here's everything else. So that live stream nature is basically allowing for us to then dictate, hey, here's the collection area that we're going to capture for this next high-res scan. So after that, in about 2 hours of showing up on site, we have rapid imagery that's being shared, which is pretty impressive from what it used to be. And then we're collecting the high resolution data. We're then going back for LiDAR. So overall, the live streams are basically happening at all times. So multi-platforms, multi-crews is giving us the ability to share that data across the board. What other questions are on there?
Next quick question, what LiDAR units are you using?
Right now, we've just been using the field deployed units. So we have been starting to test with the Voyager system, some of the yellow scan modules, and then of course the integrated one with the L2. So we are not looking for the high accuracy data at the moment, kind of just the rapid, how do we get these systems out there as fast as possible and as easy as possible. Let's see, going through here.
Yeah, there was a question. I kind of tried to answer it based off the Skydio systems, but we don't operate the DJI. So questions on the inspections for wear and tear on the airframe and cracked propellers.
Yeah, the airworthiness review, that's been an interesting item. A lot of these docks have cameras inbound, so when they come in and come out, we can inspect them. That is a current workflow, I believe, in Part 107, as well as our maintenance plans, but also an item that we're watching very closely is just what the current wear and tear is on these systems remotely. When batteries get switched out, I know that's been a big one for us, is we switch out our batteries basically every 8 months with the docks, just due to them constantly being plugged in and charging. But those are all items that we're working out as we go with a lot of the standardization with dock deployment. I don't know, Aaron, what are you guys seeing with your docks?
Similar thing. I don't have, well, we've got 2 systems that we've deployed, so 3 total platforms. We've got over 500 flights. Honestly, the biggest, as far as maintenance issues that we've seen has been things like, dust getting into the system and having to go clean the Skydio cameras. That's been the number one. And then again, inspecting the props. So on the Skydio system, there has been issues with, as that door closes, with props pinching on the X2 system. Those have been really the only 2 issues we've had. And some systems have been demonstrated that have been more reliable than others. One of our systems has 250 flights and has literally not had a single issue with it. I swapped out the props, again, because it was like, we're getting 25 hours on this. It's time to switch these, but they showed no signs of visible wear as an example.
Yeah, and that's we selected Juneau, Alaska for the installation of a majority of our docks. We wanted to see what inclement weather as far as rain, downpour. So we get a considerable amount of rain and in many cases, very close to the same amount as Kauai. And so for us, we have seen some water penetration on some of the docks, but very minimal, not affecting the operation, just it basically getting in. Not much corrosion or anything, but overall, as far as the integration goes, we're starting to move the docks further up into the Arctic. So this next year, we have a couple systems that will be at the Anchorage latitude, basically testing them for full integration with the Avalanche program. And then, of course, moving further up in the Adigan Pass, where we experience significant wind drift. I think that's been the big one for us, is just building these dock sites so that they can accommodate the wind drift that builds up around them and doesn't jam the doors when they open up. But overall, been very happy with the reliability with the systems on board. I think we hit the question on extreme temperatures, but it's an item that we are verifying kind of with the manufacturers, making sure that these systems can operate either below the manufacturer recommendation. Right now, the lowest that we've operated in is what, -55. But with that, I mean, we're making sure those risks are mitigated with Type 4 de-icer. We're making sure that it's a must fly. Batteries are warm. We're not just out there flying in those temperatures because we want to, but a lot of it has been making sure the policies are in place with the FAA to allow the operator to operate from inside of a vehicle, sometimes moving vehicle. So really developing the general operations plans for manuals for normal and advanced operations for that.
Yeah, another question just came in here from Michael Hank from our District 11 Surveys branch, actually, was battery fires were an early concern with small UAS. Does this persist with remote dock operations?
Actually, I have a great story for you guys. We got a call the other day that one of our buildings was on fire. So not a great story. But the first cause was, well, that must be all of Ryan's stuff down there that's burning because we have an EV vehicle. We have a lot of LiPos for the avalanche vehicles. Luckily for us, we store everything in big yellow burn lockers as well as when we're charging. Unfortunately, what we believe happened was AGM batteries were charging in the next bay over and potentially got overcharged. So we're definitely learning about policies, and lessons learned on when there are buildings or batteries getting charged, having a watch, no charging after hours, things like that. So, but as far as battery fires, we are very adamant on packing. Of course, we are very aviation based up here. So in many cases, we are packaging them up in the UL approved packaging. We are working with Alaska Airlines on developing a Pelican that has a burn bag and of course the procedures when we do have to fly places. So overall, yes, battery fires is something we take very seriously. A lot of our staff that are transporting these larger batteries, we are requiring hazmat certification because when we fly out to these areas, we also have to package them back up legally, which requires, once again, more problems. So we are solving it through compliance, building the correct containers and working with air carriers for a lot of this and just how we respond, as well as pre-deploying of batteries with these assets. So it's kind of a risk game of where you put those variables and moving forward.
Hey, Aaron, John again. We're down to 7 minutes of time.
All right. Perfect timing. Let's jump over to James then on the pooled fund.
Excellent. All right, so I figured the easiest way to do this is to share the pooled fund site so everybody can see what the pooled fund actually looks like, what's out there. So if you're interested, here's the actual pooled fund website. It's solicitation 1620. And what is the point of the pooled fund? Well, you just saw a ton of cool data use cases, UAS operations. But how do we get all of that data into a point where it makes sense? Do we want to collect 25 terabytes of data, or can we get away with 15 terabytes worth of data? Do we need 80% image overlap or 50% image overlap? And really, the answer is it depends. And as we kind of scroll down through here, you can see that what we're looking to tackle is survey, construction use, bridge inspection, as-builds, incident management, and earth movement. Some of those use cases will need much more fidelity in the data that's sampled, better image, better sensors, tighter management of our data sets, more ground control points. Some you've seen just our situational awareness use cases where we are just live streaming what we have. So the goal is to look through these use cases from a national perspective so that we're collecting data in a manner that makes sense, in a manner that's repeatable, and then in a manner that we can give to private sector vendors to say all of our construction inspection data is being collected at these minimums. So can you incorporate this functionality into measurement and payment applications? Can you incorporate this into change detection for rockfall? If you fly a rockfall area with one platform with one level of ground control points, and then you fly it again with LiDAR, the first one's photogrammetry, the second one's LiDAR, different number of ground control points. Can we cross-pollinate those data sets and actually do the change detection? Or we need to figure out what those minimum standards are for data collection. So that's the main goal of this. It's a 5-year pooled fund because pooled funds have to be 5 years long. But some of these are pretty much solved problems. Many states have UAS in their survey specs already. So it's looking through those states and seeing, what's working well, what's not working, finding the best examples and putting that out there. So surveying might be done within a year or less. Some of the higher, more complex ones might take 5 years. Bridge inspection will have a regulatory element. It's not just validating sensor capability. It's then having to work through the regulatory elements as well. So that might take more in the 5-year time frame. The website is a bit out of date. The pooled fund does, I believe, have 6 other states give or take, that have joined as well. And we're just waiting on the website to be updated. So we're getting pretty close to having at least the initial round of funding to kick this off. Ryan and Aaron are leading this effort. So if you have detailed questions on timeframes and specifics, feel free to reach out to them. But Federal Highway has already signed off on the waiver to move this thing forward as easily as possible. So financial considerations from Federal Highway won't hold anything back. It's ready to go as soon as the minimum state participation is met. So with that, and recognizing that there's 3 minutes left, I will leave that for any last lingering questions or comments. Hearing none, I think I'm handing it back to John to close us out.
Yeah, thanks, James, and special thanks to Aaron, Timothy, and Ryan, and Jacob, I think. Hopefully I didn't miss anybody for the presentations. Those were certainly enlightening. I know I have a role here in UAS and definitely learned some things from those. So we appreciate that. Appreciate everybody attending. Those of you who will be in Iowa, I look forward to meeting you. And if you're not attending Iowa and these type of presentations interest you, then HEAP is a good organization for you to consider for consideration for attending next year's event and keeping an eye on what we publish throughout the year. So with that, I think we can go ahead and end it. Thank everybody for their time.